Today we're going to be learning about Pythagoras, and in this video we're going to go through a brief history. We're going to look at why Pythagoras works and then go through a few examples. So on this slide here I've got a picture of Pythagoras and his very useful formula over here. Now Pythagoras was a philosopher. He lived around 570 BC. And for part of his life, he lived in Egypt, where he just became obsessed with maths and fell in love with it. And because he was in Egypt, where they've got these big pyramids that actually used Pythagoras' theorem in their creation, it's actually speculated that Pythagoras did not invent what we call Pythagoras' theorem. And there's a video that's really quite funny that I'm going to get you to watch next lesson that goes into more detail about that. So this is his theorem here, and we're going to do a little investigation on why it works, whether it's his theorem or not. Diagram here to hopefully understand a little bit more about Pythagoras' theorem. Now the first thing that you need to write down is this statement here. Pythagoras' theorem is used to find an unknown side length in a right-angled triangle. So just like we talked about when we went through algebra, we need to know everything except for one thing to enable us to find that unknown value. So if I've got A or B, I can find C. If I've got C and B, I can find A, but I need to know two of those things. Now when we have a look at this, this theorem is saying that A squared plus B squared, so this square here plus this square equals this square. Now what that means is the area of A squared plus B squared actually fits exactly into C squared. And if we're at school, I'd get you to do a little investigation on that, but instead for today, and I'll link these on the lesson plan, I've got these two videos that show you two different methods of putting or fitting those two smaller squares into that bigger square. So please go and watch that after this. So the thing we need to also know is we've got a right angle, and opposite that right angle we call this side, we give it a special mathematical word, and it's called the hypotenuse. And so your C value is always that hypotenuse side. It doesn't matter which way you label A or B because we're just adding them together, but you need to make sure that that C is the hypotenuse. And I think we may be ready to go on to our first example. I like to call this type of setup a case 1, and this is where we're given two of our shorter side lengths, and then we're trying to find that hypotenuse or the longer side length. And what that means is when we use this formula directly, there's very minimal rearranging to get our C value. Okay, so I'm going to choose an A and a B. It doesn't matter which one. So 8 can be A and 10 can be B, which makes this C. So our hypotenuse is always our C. So we've got A squared plus B squared equals C squared. I'm going to substitute those values in. So 8 squared plus 10 squared equals C squared, or let's rename that K squared. So we've got K here. And then we've got 64 plus 100. So 164 is equal to K squared. Now I need to get rid of, or I need to remove this square on the K. And to do that, hopefully you remember that the opposite of a squaring a number is a square root. So I'm going to take the square root of both sides, and that's going to undo that on this side. So I'm left with just K. And then on this side, I'm left with 12.81, or, so this would be the approximate answer, 12.81 centimetres, remembering to include my units, or our exact value would be, and this might take a bit of thinking, would be to find some factors of 164. So 4 might be a factor. Yes, 4 times 41. And that's going to simplify to 2 root 41 centimetres. So this is our exact answer and our approximate answer. Okay, this setup here is what I like to call case 2. And what we've done to the formula, and I'll just write this out here, is usually I'd have a squared plus b squared equals c squared. When I've got the hypotenuse and I'm finding a shorter side length, it can be useful to use this setup of the formula, and it's just been transposed, so there's less rearranging. So all I've done is moved that b squared over, subtracted it from both sides to end up with this here. Okay, so let's identify our hypotenuse. This is my right angle. Opposite is the hypotenuse, so that's going to be my C. And again, it doesn't matter which side length you label A or B, but in this case, we've got A as the subject on this side. So let's label B this one and A this one. So let's write out our formula. Now I'm going to substitute in what I know. So P squared equals 22 squared minus 8 squared. Now 22 squared minus 8 squared works out to be 420. And then we've got P squared. So it's the same process again. We're trying to remove that, that square from the P. So we're going to take the square root of both sides. And what I'm left with is just P, because those two cancel out because they're the opposites of each other. 20.49 centimeters, or our exact, and again these factors can be hard to pick up on, 4 times 105, which would give me 2 root 105 centimeters. So is that exact, and approximate.